In April 2024, Reuters reported that Tesla had quietly cancelled its low-cost car project due to pressure from Chinese EV competitors. Elon Musk immediately denied it, posting, "Reuters is lying." 1 year later, real-world developments speak for themselves. Tesla is not stepping back. Gigafactory Texas, Gigafactory Nevada, and Tesla's Megafactory in Lathrop are all under active expansion specifically to support production of a new compact vehicle platform. Tesla's first showrooms in India are around the corner, while many more likely to follow across Europe. Though Tesla has not officially confirmed the Model 2 by name, industry patterns and factory investments strongly suggest that mass production for the 99% is already in motion with breakthrough technology that Chinese automakers simply cannot match. Powered by next-generation axial flux motors and quantum-enhanced graphene 2680 batteries structurally integrated into the vehicle, Model 2 is clear proof that Tesla was never retreating. Before diving in exactly how Tesla turned doubt into dominance, make sure to subscribe to westtech and help us reach 134,587 subscribers. And do not forget to turn on notifications so you never miss the latest Tesla breakthroughs. What's the secret behind Model 2's surprising performance? What's the secret behind Model 2's surprising performance? One of the most critical breakthroughs hidden within the Tesla Model 2 lies in its adoption of axial flux motors, a technology Tesla has never before applied in its mainstream vehicles. Unlike the radial flux motors currently used in all Tesla models, such as the Model 3 and Model Y, axial flux motors feature a completely different structure and performance profile. Instead of a long cylindrical shape, these motors are flatter with a disc-like structure measuring just 80 to 100 mm thick compared to the 200 mm or more found in radial designs. This unique layout allows magnetic fields to run along the axis of the motor rather than radially outward. As a result, laboratory tests and real-world applications have shown that axial flux motors deliver up to 30% higher efficiency in converting electrical power into mechanical torque, especially at low-speed urban driving where traditional motors lose efficiency. There are solid engineering reasons behind Tesla's decision to make this switch. Torque in an axial flux motor increases with the cube of the rotor diameter. For example, expanding the rotor's diameter from 250 mm to 300 mm can boost torque output by more than 40% while maintaining the same motor thickness. This means that Tesla engineers can achieve peak torque figures of over 500 Nm from a single compact motor unit, equivalent to what larger dual motor setups deliver in current EVs. At the same time, these motors are up to 50% more compact in total volume than equivalent radial motors. This smaller size frees up approximately 70 to 100 L of internal vehicle space, allowing Tesla designers to lower the center of gravity by up to 15 mm and create more flexible interior layouts for both passenger cabin and trunk storage. Another key advantage of Tesla's axial flux motor lies in its natural thermal management. Thanks to its disc-like geometry, heat is dissipated more evenly and efficiently across a wider surface area. Traditional radial motors rely on internal cooling channels that can create uneven thermal zones, whereas axial flux designs reduce peak heat concentration by up to 25%. This ensures stable performance even under repeated acceleration or in hot climates above 35 degrees Celsius. For everyday drivers, these improvements bring measurable benefits. Acceleration feels smoother and more controlled with a steady, linear response from 0 to 60 miles per hour in just 5.9 seconds, outperforming most compact EVs in its price class. Thanks to reduced energy loss, real-world range per charge using the same battery capacity improves by up to 15%, which translates to an extra 30 to 40 miles on a standard 300-mile rated battery. Ride quality also steps up as axial flux motors produce up to 30% less vibration and noise compared to radial flux alternatives, reducing cabin noise levels by an average of 3 to 5 dB. Crucially, this simplified, flatter motor design includes 25 to 40% fewer moving parts, requiring less frequent servicing and eliminating common wear points such as internal bearings or seals. For Model 2 owners, this translates into lower long-term ownership costs, averaging $600 to $1,000 in maintenance savings over a typical 8-year period while delivering a quieter, more stable, and more comfortable drive every day. Quieter, smoother, more efficient. Does that sound like your kind of EV? Comment Model 2 if you would actually drive one. What if the biggest change in Tesla's next car isn't the shape or the speed, but something hidden deep inside like that? 2. What if the biggest change in Tesla's next car isn't the shape or the speed, but something hidden deep inside? A breakthrough quietly developed by Tesla since 2023 is set to redefine battery technology. The quantum-enhanced graphene 2680 battery with structural integration. This next-generation battery is expected to debut with the Tesla Model 2. Unlike existing lithium-ion cells used in all Tesla vehicles today, these new cells replace traditional graphite electrodes entirely with graphene layers for ultra-fast conductivity, combined with a precision-controlled quantum dot layer that manages temperature in real time. This integration combines the raw power of graphene with the fine control of quantum dots, all packaged in a compact 2680 cell size featuring a tablet design. Tesla's choice of the 2680 form factor instead of the more widely discussed 4680 cells is deliberate. These 2680 cells are approximately 40% smaller than 4680s, making them a perfect fit for a compact EV like the Model 2. The smaller form allows for more flexible battery layouts within the vehicle structure and makes manufacturing easier, reducing waste materials and lowering production costs by an estimated 25%. The optimized surface area to volume ratio of 2680 cells enables better heat dissipation, essential for quantum dot thermal control. If one cell fails, it is easier to replace without affecting the entire battery system. Central to this battery is Tesla's quantum dot thermal management. Quantum dots embedded within the battery emit different light wavelengths at varying temperatures, allowing for precise real-time thermal monitoring and adjustment. Graphene's ultra-fast electrical conductivity works together with the quantum dots to automatically regulate current flow when the battery heats up, preventing degradation and extending lifespan. Thanks to the compact form factor, heat is distributed more evenly across the battery pack, minimizing hot spots. Over time, the battery learns from each driver's usage patterns, optimizing its own temperature settings for maximum efficiency and longevity. Structural integration represents a complete redesign of how Tesla uses batteries in its vehicles. Instead of housing the battery pack as a separate unit like in the Model 3 or Model Y, the graphene 2680 cells are integrated directly into the vehicle's frame. This means the battery becomes both an energy storage system and a load-bearing part of the structure. Quantum dots help spread heat uniformly across the chassis, eliminating the need for complex cooling systems. The 2680's smaller size allows for flexible cell arrangement throughout the structure, contributing to both safety and space optimization. The technical benefits of this integration are substantial. Tesla estimates a 30% reduction in total vehicle weight and a 40% increase in frame rigidity. Battery energy density improves by 20% in the same physical space, while thermal stability is enhanced thanks to quantum dot control. The more compact battery layout also frees up additional room in the cabin and trunk, improving passenger comfort and cargo capacity. These innovations have direct effects on real-world driving. The lower center of gravity improves cornering stability. Lighter weight means quicker acceleration and better braking response. A quieter cabin comes from the integrated structural design absorbing vibration more effectively. Crash safety is also improved as the battery structure helps absorb impact forces. Most importantly, these advances make the $9,875 price tag of the Model 2 possible. The quantum-enhanced graphene 2680 battery accounts for around 22% of the car's total cost. Compared to equivalent lithium-ion batteries, this setup saves Tesla and consumers approximately $6,500 per vehicle. With rapid charging from 0 to 80% completed in just 6 minutes, drivers no longer need to worry about range anxiety. The battery's compact size allows home charging at 110 volts in a surprisingly short time. Its lifespan is equally impressive, increasing from the current industry standard of 300,000 miles to as much as 1 million miles. When mass production begins in 2026, Tesla expects battery production costs to fall by up to 65% thanks to easier manufacturing and less reliance on rare materials. Do you think Tesla's quantum battery gives it a real edge over Chinese EVs or not? Comment Tesla wins if you believe it does. How does the Tesla Model 2 quietly redefine what smart features in an everyday car should actually mean? 3. How does the Tesla Model 2 quietly redefine what smart features in an everyday car should actually mean with the Tesla Model 2? The focus is not on flashy self-driving features or oversized screens. Instead, Tesla introduces a concept it calls smart living, a system of quietly intelligent technologies designed to reduce stress, save money, and make daily driving simpler and more dependable. At the core of Tesla's smart living system in the Model 2 is adaptive learning, designed to make everyday driving more convenient and efficient. Over an average 2-week period, the car automatically learns your regular routes, departure times, and charging habits. Combined with route and charging optimization, Model 2 not only selects the most time and energy-efficient driving paths using live traffic and charging station data from over 50 million vehicles worldwide, but also adjusts its charging schedule based on electricity rate fluctuations. In the United States, where peak and off-peak rates can vary by up to 40%. This system can save drivers between $200 and $300 annually on energy costs. In regions like California or Texas, smart home integration further enhances savings by automatically charging during low-rate periods, cutting home charging costs by up to 50%. Beyond route planning and charging, Model 2 improves long-term reliability with predictive maintenance. By monitoring over 120 key vehicle components through advanced sensors, it can detect early signs of wear and alert the driver before any failure occurs. Tesla estimates this proactive system reduces unexpected breakdowns by up to 70% compared to traditional cars. There is also a feature called climate intelligence which keeps the cabin temperature automatically adjusted according to outdoor weather and personal preferences by avoiding unnecessary heating or cooling, especially when the car is idle. This feature helps extend driving range by up to 5% in everyday urban conditions. Finally, Family Mode personalizes each drive instantly using seat sensors and key profiles. The system recognizes who is driving and automatically adjusts seat positions, mirrors, and even music volume. Tesla reports this automation reduces setup time by over 80% compared to adjusting settings manually each time. What truly sets Model 2 apart is how these features work quietly in the background without requiring constant internet access or cloud services. Tesla has deliberately avoided unnecessary voice assistants, light shows, or hidden Easter eggs. Instead, the car focuses on reliable long-term functions that directly improve your daily life. Shorter routes, cheaper charging, safer driving, and a smarter vehicle that keeps learning as you use it. What quietly makes a $9,875 Tesla possible for? What quietly makes a $9,875 Tesla possible? One of the key reasons Tesla can offer the Model 2 at a starting price of $9,875 lies not just in design or battery breakthroughs, but in a complete transformation of how the car is manufactured. Tesla is pioneering what it calls lights-out production, a system where up to 80% of the entire assembly process is handled automatically by robots with minimal human intervention. At the heart of this system is the Optimus robot designed to handle complex assembly tasks traditionally done by skilled workers. Combined with Tesla's unboxed process, which reduces the number of manufacturing steps by 50%. This method allows cars to be produced around the clock 24 hours a day without the need for rest breaks. This level of automation has direct consequences for affordability. Labor costs are reduced to near zero during the core production phases. Precision manufacturing eliminates waste material almost entirely, making each car more resource efficient. Production time per vehicle drops from the industry standard of around 30 hours to just 10 hours. Quality control is also upgraded through full AI-powered inspection systems that check every component in real time, ensuring that each vehicle meets exacting standards without relying on random sampling. The shift to highly automated production does not eliminate jobs altogether. It reshapes them. Tesla's expanded Gigafactories are expected to create around 50,000 high-skilled technical positions across the United States. Many of these roles involve operating, maintaining, and programming advanced robotic systems. In parallel, Tesla is investing in retraining programs for workers coming from traditional automotive manufacturing backgrounds, helping them transition into new roles that support this cutting-edge production model. Tesla's supply chain is also evolving. By focusing on domestic component production, the company reduces its dependence on imports from countries such as China. This approach strengthens the local economy and increases supply chain resilience, especially in areas like battery materials, electronics, and structural components. All of this ties into the broader goal of making the Model 2 a true made-in-America product. By building the vehicle entirely within the United States, Tesla ensures that the Model 2 qualifies for the latest federal tax credits aimed at encouraging American EV manufacturing. This gives Tesla a clear competitive advantage over lower-cost Chinese electric vehicles, which face increasing regulatory and tariff barriers. More importantly, it reinforces Tesla's identity as an American car company committed to both innovation and local economic growth. As the noise settles, one thing is clear. Tesla never cancelled its low-cost car plans. It kept building quietly, step by step, and the Model 2 is the next chapter already taking shape. While others talk, Tesla prepares to deliver a $9,875 EV made for real drivers, real families, and real roads. To keep up with these updates, make sure to subscribe to westtech and turn on notifications. Your next car might already be rolling off the line.